Coach Jay coming to you live. This is all the way from my same room, same everything. We just sitting on the floor today, you know. I've got this. Oh, I've got a visitor. Hey, you want to come and say hi? Come on, say hi. Say hi, everybody. We got the same visitor over here, and yes, she loves this song. Are you ready? Here we go. Ready? 1, 2, 3. Oh, one more time. 1, 2, 3. Oh, maybe next time. Hey, can you give Daddy high five? That's what happens when this is what happens sometimes with kids. Totally got rejected there. Not just the basketball side. I was totally rejected. We are ready to roll. This is Chapter 4 podcast. We are excited to get it started today. I hope you're excited too. And got a lot to cover today. Heads up, please make sure if you do have any questions regarding any of these podcasts, please make sure you let me know. Send it to the YouTube link, or if you want to, send it to me, and I'll kind of try to keep this up and running. In fact, I'm going to pull it up now. I've forgotten. Pull that down. But if you have any questions, just throw them on the message board. I apologize that it's a little early today. Tonight got some neighbors we're doing some stuff with, and so we'll keep it rolling. So feel free, again, if you do have any questions, just post them right there. I see the chat on this side. Let's see, show it there, and here we go, posting that. Perfect. And I will continue to update that and look at that about every 5 or so minutes on there, okay? All right, so with that being said, let's talk about a couple things that let's just talk about a couple things we've talked about. Let's talk first about this block versus stratified. Remember, stratified is talking about the cloud, right? We have this cloud coming through. With strata, we have multiple clouds, if you could think of that, right? And remember, freshmen, these are not representative of the population, right? So if we were thinking of all of GAC, one of these clouds is not representative of the population. So I couldn't randomly select one specific cloud and then sample everyone inside. Now, within a cluster, we talked about this would have freshmen, sophomores, juniors, and seniors, right? And let's say each of these clouds did, right? We had all these homerooms that were representative of the population. I could take a simple random sample where I could just select one of these clouds, and in a cluster form, I could select it. And when I selected it, I would sample everyone within that specific cloud, right? While with stratified, it's a little different. Remember, we'll take a simple random sample from this. Let's say it's a total of 20, right? So maybe it's 20 from each, okay? I see a question here we're going to get to here in a second. But the idea is that I would continue to pick 20, 20, 20, and 20, and we would go from there, okay? All right. And I'm realizing I forgot to send out the links. I apologize. I am totally in left field. I am coming here. Jordan, thank you for that. I really do appreciate that. It is coming right now, okay? So those that are coming in late obviously didn't have the link there. Send it to people. My apology on that, but it is coming. All right. So you might be a little bit behind, but that's okay. Follow me through, and we'll go from there. Okay. So we've got 20 on each of these, right? 20 on each of these for a total of 80. But remember, with the stratified, I take 20 of each, right? This is a stratified. Remember, this is observational. Okay, that's very important. Observational. Whereas if I talked about a block design is where I divided into 2 groups, right? Let's say I had 80 total people that I was surveying. I divide them up into juniors and sophomores. And let's say I had 2 treatments, treatment A and treatment B. I would first represent this with a block. By the way, this block is not, that's not random, right? However, this part and this part would be. So treatment 1 and treatment 2. treatment 1 and treatment 2 would be. But the block is set in place so that I almost have too many experiments going on to see which treatment really is impacting, which treatment works better, or is there an impact that's felt there, okay? Remember, this is experimental, right? So when we talk about a block design, that's experimental, but a observational side would be stratified, okay? Awesome. Sweet. And yes, today, just a heads up, tomorrow the notes are due, just the one-page notes. Feel free to kind of make that what you will there, okay? All right, let's talk about a completely randomized design. Let's say I have 100 different individuals, and let's say I take let's talk about a simple random sample first. And let's say out of those 100, the 100 is my population, right? Let's say that in that I take 10 out of that population to sample. That'd be an example of a simple random sample, especially when I'm doing observational, right? So this would be more observational. However, if I was doing a completely randomized design in terms of, let's say I had 100 people and I was trying to figure out which would go into which treatment, right? Treatment 1 and treatment 2, right? I would have randomization with this 100 that would go to treatment 1 and treatment 2. The fact that I'm imposing a treatment allows me to then be a completely randomized design, okay? So I hope that makes sense. Completely randomized design is more of an experimental, whereas a simple random sample, though it's choosing n specific units, right? They each have each n group of units has a specific has the same chance, right? I would just be sure make sure SRS definition's huge for tomorrow. So just make sure you hit on that. Again, a good example is number 5 on that old quiz. Okay, excellent. Now let's talk about definitions and examples. I would highly recommend looking at the observational and exponential chart where you wrote in those specific things. Know those definitions. Know really more, how do I apply them? Okay, that's a huge deal there too. The multiple choice questions, we're going to go through there, and probably should have put this, but how do I answer an FRQ? The more FRQs that you do, the better. And I'm not talking just like doing them. There's a couple of individuals in the class that maybe forgot to do them or maybe didn't do them as thoroughly. And the problem with that is that you didn't get what you needed within that FRQ. And you really got to pour yourself into those FRQs so that you really truly understand either what you got incorrect or how you approach it, because tomorrow is going to be very, very similar to the ones that we've experienced the last 2 days, okay? And then obviously the 2 extra ones that you see down at the bottom of that sheet as well, okay? Awesome. I do want to, as I go through this, continue to check to see if there are any questions that are there. I know that, again, I knew there were probably a couple of questions that I just want to make sure that we address. So if you do, please make sure you touch base with me on that, and we'll continue to go through that together, okay? So put it on the right side here, and we'll rock and roll, okay? Rock and roll. Also, if someone could, just be sure to throw a little shout out on that right side. Make sure that all is well. If something's messing up, please let me know, and we'll go from there, okay? Okay, why is randomized important? Remember, randomization protects, this is huge, huge for my FRQs tomorrow, protects against over and under, overestimates and underestimates of the population, right? Okay, remember, observational, or really overestimates and underestimates it could be like the population that I'm looking at. It also could be it could be a lot of different things. Really, randomization just protects against over and underestimating. When we talk about even experimental, right? When we do the completely randomized design, we try to be able to get as accurate as possible, the measurements as accurate as possible. Now, will we get perfect? No, but when we randomize, the law of statistics allows us to see, like, it will balance out in the long run, right? The higher the amount of, and this is a good thing too, the larger sample size. what do we do with our hands? We decrease variability, right? So remember that. That's a huge, huge deal. It decreases variability with a larger sample size, okay? Also, this doesn't eliminate bias altogether, but it decreases bias. Sometimes you could still be random and have bias by the way that depending on what you're randomizing there, but decreases bias, especially if we're talking about depending upon the study. That's definitely true there. Okay. All right, look at this last one. Probably the one that probably confused everyone the most. Pretend like that I was doing a study on with two different things. That there's two different things that I was using. Okay, so I'm going to assess cereal, and we'll just talk about cholesterol. Okay, cholesterol, and we'll talk about this as medicine. Okay, this will be medicine. All right. And what we'll do is we'll say that in this medicine, okay, kind of roll it down here, okay. In the medicine, we're going to give vitamin A and vitamin C, okay. All right, so actually we'll just say medicine, we'll just call this vitamins, okay. And in the cereal, we're going to say Cheerios. And over here, we'll say Raisin Bran, okay. So let's say my subjects were to have a specific cereal every morning with a specific vitamin, right? So what I have is 4 different groups where my subjects, right? Those are my experimental units. That's a form of experimental unit where my subjects will have to engage with 2 of these things, a cereal and a vitamin, okay? So down here, this would be the people with Raisin Bran and vitamin A and vitamin C and Cheerios right here and so on and so forth. So with this, we have different factors that we have here. The factors involved with this treatment, right? The treatment's like what's being given, but the factors that are involved include cereal and vitamins, right? Those are my 2 factors. Now, within these factors, we have also different levels, right? In fact, there's 2 levels right here for cereals, and there's 2 for the vitamin A and vitamin C. So again, just something to keep an eye out for. Nothing, just some things that I would just mention and then kind of go from there, okay? All right, let's take a look at this one. This is an FRQ that I wanted to open up with, and then we'll go straight into our multiple choice questions. So feel free to get this down. Use this on your Chapter 1 notes. Anything we're talking about is free game there, okay? And again, let me check to see if there's any questions on the right. Oh, okay, good. Okay, I got some questions here before I begin. SRS definition from the quiz. Simple random sample definition, a sample of size n chosen in such a way that every set of n units in the population has an equal chance to be the sample actually selected, okay? So it's the sample of size n, right, whatever the sample size is, chosen in such a way that every set of n units, right? So a good example of that is if I chose 5 units, right? So any set of n units in the population that has an equal chance to be the sample actually selected, right? So by the way, that is random. That is part of the definition of random. What I messed up on is simple random sample is a more in-depth definition on that. And that's where I was there, okay? Shout out to Matthew, by the way, for going in the fountain. I cannot believe. Just real quick, Matthew, I just want you to type in there. Did you get in trouble for that in the next class? Please tell me you did not get in trouble for jumping in that fountain. And oh, by the way, please send me the video because I'm going to talk about dedication at some point, and I'm going to have to use that video. So please put that out there, okay? I mean, Beyonce, not Matthew, of course. Of course there, okay? All right. Oh, good. Okay, good. You did not get in trouble, everybody. So there you go. All right, let's look at this FRQ here. It talks about in the interior of a house, each window is surrounded by a window box to capture and measure the amount of heat coming in through the window and to isolate the heat gain for each window, okay? All right, so the question, well, first off, we have different ways the sun's coming in, from the north, from the east, from the west, and to the south, right? And so you'll see that there's different ones there. Now, let's see. It says, make sure. I'm going to read back up here just to make sure. So in conducting an experiment to compare the heat gain in houses using two different types of windows, A and B. 6 windows of each type are available for the experiment. The department has constructed a house with 12 windows as shown on the floor plan below. Okay, so it doesn't tell me what is A and what is B. Let's take a look at it and let's see what we got here. Okay, all right, question A says this. A randomized block experiment will be used to compare. Okay, here's the key. I highlight keywords, block and random. All right, so here's the deal. We don't know exactly, like we don't have to actually use that chart that we did, but sometimes that might be helpful. So for right now, just so that you can see it, we have 12 windows, right? Okay, so we've got 12 windows. Experiment, each will be used to compare the heat gain for the two types of windows, okay? How would you group the windows boxes into blocks? Okay, so how would I do the blocks? That's the question. So by the way, when I block this off, is it random? No random here, okay? Not yet. So this is no random, not random yet, okay? So we're gonna block them off into block 1, 2, 3, maybe 4, I don't know. Let's take a look at it though. Let's go back to the example. We notice that, let's say the sun is on one side, right? Don't you think that the heat would hit the house differently on the one side compared to the other? Maybe there's something on this other side. Maybe there's another window, or I'm sorry, another house that's blocking, or something of that nature. And so we want to be careful that we don't just completely randomize, because it could allow us, or could impact this by allowing all these windows on this side to experience the sun. And because of that, we might falsely state that window A is worse than window B, or whatever that may be. So we've got to be able to take this in blocks, and it seems like it's pretty easy because the blocks are literally the sides of the house. So we would have north, south, east, and west. And so if I were to do this, I would say windows in the north, right? East, I would write this out, south and west, okay? And I would block them off that way. And I would say, okay, window 1 and 12 are here. 1 and 12 are north, okay? I believe west would be 11, 10, 9, 8. I want to make sure of that. 11, 10, 9, 8. Good. 7 and 6 are on the south, okay? And 2, 3, 4, and 5 are on the east. And so I would block them off this way. So right now, I've blocked it off. I would say that. How would you group this? Clearly indicate your blocks using the window box numbers, okay? So I would say window box numbers, and I would list them out, okay? All right, so that's how I would block them off. Now the question is justify your choice of blocks. And I would have to say something along the lines of, due to the sun hitting the house at different times of the day with different intensity, something along these lines, right? Different intensity. Each side of the house will allow more or less sunlight in, okay? Now, what I'd like to do is just kind of read this was my definition, so let's see if they, let me read this out loud, because this might be good here, just for you to kind of hear this. Here's what they said. They said, and I like theirs probably a little bit better. Based on this definition, I would put the windows into groups that have something in common that has to do with sunlight, since this relates to heat gain in the house. Now, I kind of said that. One thing that I probably should have mentioned, with different into each side of the house will allow more or less sunlight. And I probably should have said, this is why we block north, south, east, west sides of the house together. Okay? Now, that's a lot more wordier than what they said. and if you want to go back through and actually listen to what I had said again, this would work. But that again would be what we're looking for. Okay. B says this: for the design in part A, describe how you would assign window types to the numbered window boxes. Okay, think about this. For the design in part A, now let's remember this. This is where maybe our experimental would come into play. So we have north, south, east, west, right? Here's our 4 blocks. Now remember, it says we want to assign them, right? But remember, it's a randomized block experiment, right? So we're going to do random assignment here. Random assignment, right? And what are we going to do? Well, we're going to split these groups up into A and B, okay? A and B, okay? All right, so we would go like that, and then from there, right, we'd randomize it, and then we would compare, right? We'd compare here, we'd compare here, because again, we can't compare the north and the east or the north and the south because it might be getting different intensities, and then that would not provide equal, like it would not be, like it could be by chance that there was a lot of A's on the west side or a lot of A's on the east side where maybe it wasn't as intense or it was more intense. So we want to be careful of that. So remember too, like for instance, if this was north, we want to identify that the north side, and I actually, north side, there were 2, right? So one would be assigned to A and one would be assigned to B. For the east here, we would have 3 and 2, I believe, right? Or no, 2 and 2, my fault. 2 and 2, right? That we would assign to both of these, right? And same thing here for west and south would be 1 and 1. Okay, and then we would compare it. So how do I put this in words? Well, what I would say, and then I'll go to it. So I don't want to write all this out to waste time, but I'll show you the answer to this so you could see it. But I would say, in looking at the 12 windows and putting them into blocks based upon the sides of the house that they were in, we would then randomize the north, east, west, and south. We would randomly assign windows within each of those categories. To do this, we would use a table of random digits, and for the north and the south, we would label our range would be 0, 0 to 0, 1. And then we would go to table of random digits, look on there, and ignore any values that were outside of my range of 0, 0, and 0, 1, and ignore any values that also were repeated, right? So we could do that. And then we could also say for this one, we could also kind of identify when looking at a table of random digits from 0, 0 to 0, 1, we found that whatever one was stated first, let's say 0, 0 was picked first, we put that with window A, and the other, that means the other value, 0, 1, would be the one that was left over for the window B. And you could do the same type of thing with the east, and then at the end just say, after analyzing over the course of time, we compared window A to window B for the north, east, west, and south side to see which window would be the best there, okay? Now, just to kind of give a better idea here, okay? Let's see. I like this. Let's look at this part. I like this part, okay? Yeah, okay, so let's see what they said, because I maybe could have done this a little bit better. In each block, we need to randomly assign half of the windows to A and half to B, okay? Use a random number generator like a coin or calculator where there are 2 outcomes. You could also do the random table number. That's fine, what we've been talking about, okay? This also, because of a coin and a calculator, random number generator, as long as you say calculator, it looks like we're good, okay? In block with, you could have said in block with 2 windows, use the generator once on the first, well, actually, we need both of these, right? In blocks of 2 windows, use the generator once on the first number window, assigning it to the correct treatment. Then the other window would be the opposite treatment. Again, I said A, you could have said A or B, it does not matter, and then go from there. We use the next one with 4 windows, we use the generator once on the first numbered window, assigning it to the correct treatment. Repeat this for the second number window. Continue this until you have 2 assigned to A and 2 assigned to B, okay? Again, I said the same thing. I just said, hey, we'd have 2 numbers that we had chosen from whatever the two numbers that were, in our range there. And then from there, then we would say the two that were selected are in Windows, would have in Windows A, and the other two selected would be Windows B. Okay. All righty. Nicely done. Hopefully that helped y'all. If you have any questions on that, hopefully that provided a little bit more information there. All righty. Let's see if there's anything else. Matthew did not get in trouble, which is good. I can't believe you did that. The other class came in and I was like, what just happened? I feel like you won't be talking about dedication. Video creds to me. He does deserve a ticket. I'm going to give a ticket. I don't know why I'd give a ticket to that. That stays within our team there. Oh my goodness. Wow. Okay. This is fun. I love this. I love podcasts, y'all. APStats podcasts are my favorite. Okay. Let's go to the multiple choice. You got that? Let's go to the multiple choice. We got about 15, 20 minutes to do some multiple choice here. I am going to go over the multiple choice that are linked to the bottom of this section. This is chapter 4. Feel free if you need to go over some or whatever. Feel free to go through them. Here's the thing. There is no math in this. Someone told me today, they're like, Coach, we didn't do any math whatsoever. And you'd be right by that. We actually did no math whatsoever, which is kind of crazy. I know, but I know that we can definitely we'll get through it for sure. We got this one. The big thing is just kind of understanding the application of the material and moving forward on this. And then the next chapter will be extreme on that for the in terms of math there. Okay, so let's take a look at this one. The first one, we'll just start there. Which of the following are true statements? In an experiment, and I always like to do this, I always like to mark, or maybe I'll put a question if I'm confused and kind of go from there, okay? Sample surveys are experiments. Incorrect. So if I cross that one out, I automatically know that these are false, okay? They're gone, okay. Sample surveys are not experiments, they're observational, okay? All right. The next one says, the number 2 says, in an observation or in an experiment, some treatment is intentionally forced upon one group to note the response. Yeah, that's true, right? This is a treatment, right? That's intentionally forced. Yeah, that's good. Number 2, in an observational study, information is gathered on an already existing situation. Study is gathered on an already existing. Yes, this is true. We're just observing, right? It's already existing. It's observational. D would be the right answer. 1 and 2 are both correct, okay? All right, number 2 says, in one study on the effect of nicotine on cholesterol level, 100 subjects to a knowledge being long time nicotine, sorry, I'm cutting off there, takers had their cholesterol levels compared, okay, with those of 100 people who had never taken nicotine. In a second study, 50 subjects were randomly chosen to receive nicotine and 50 were chosen to receive a placebo. All right, so let's talk about this. Let's first talk about this last part. The placebo means that like a sugar pill. Think of sugar pill. Doesn't really impact it, but we have to do that because of the fact that one is receiving nicotine and the other this placebo that's there, right? Now let's look up here. 100 subjects who acknowledge being longtime nicotine takers had their cholesterol levels compared. Okay, so these were just comparison, right? Okay, so I think on the bottom we can say that's probably an experimental. The top might be, and I haven't looked at the answers. Top looks like we're just comparing things. We're not forcing a treatment. So this would be more observational. So let's see if we're good. Both studies were observational. That's not true because I forced a treatment, right, on the second one. Both studies were controlled experiments. Again, not true. Okay, not true on that. Each study was part controlled experiment. Well, there is no control group, right? A control group is someone who doesn't take anything, right? Even a placebo group, that's not a control group. That control group is something that is it's not receiving. It's not receiving anything, okay? Each study was part controlled group and part observational. That's incorrect. The first study was a controlled experiment while the second was an observational. No. And actually, I want to go back and retake that back, what I just said. I want to take back what I just said. Okay, let's look at this. It says the first study was a controlled experiment. That's incorrect because it's observational. And I said an incorrect statement mainly because I thought I knew, but I think I got this a little bit tweaked a little bit. Okay, it's B. We know it's an observational study. We know this is an experiment, right? The reason why this was a controlled experiment was because of the placebo, right? We were given a control group. It was, well, and I don't even necessarily, when it says it's a controlled experiment, it means that I'm putting into two different groups. I want to look at what the definition of controlled experiment is. That was not something in our notes, and I just want to make sure that I get that right. So I want to say it to you just in case. It doesn't even come up. Does it come up at all? Controlled group. Oh, controlled experiment. I'm sorry. That's what I was looking at. A controlled experiment, independent variable is the only factor that is allowed to be adjusted. Okay. That the independent will vary in. Okay. Let me see here. I want to see this video or this picture. Okay. Okay. So, okay. Yeah. And this is what I was wondering here. Okay. So coming back to this, the fact that this is a sugar pill, even though, this is actually the control group because of the fact that even though they received something, they didn't receive the actual treatment. So because of that, they did the placebo just to protect against the placebo effect. But because of this, I was incorrect with what I said earlier. This is actually a control group. Therefore, the second's a controlled experiment. Again, B is our answer. I knew that. I just wanted to make sure that I correctly identified that if that was a control group and we were good to go. So I just wanted to make sure I was good to go on explaining that to you. Question 3, suppose you wish to compare the average class size of mathematics classes to the average class size of English classes, okay, in your high school. Which is the most appropriate technique for gathering the needed data? Suppose you wish to compare the average class size of mathematics classes to the average class size of English classes in your high school. Okay, so here's the thing. If it's all of my high school, right? How many math classes do we have? Like, I don't know, like let's say, I mean, we've got 7 teachers, like let's say we have 35, right? In English, let's say we have like 35, okay? So what we could do with these 35 right here, okay, is that's not very large, right? So we wouldn't have to conduct an experiment to gain all that. And I would even say that a sample survey, like I don't want to survey people to say, how large is your class, high school, how large is your class? The easiest thing to do is just take the 35 of each of these and say, okay, what is my average class size here? What is my average class size here? And when I do that, really what we're doing then is saying, okay, observational study or census. Well, we are observing this, right? But really remember, a census, an observational study, a lot of times is randomized, right? We're observing and we're finding a random sample from that. So because it's such a small population, the easiest thing to do would be just to take the census of it, meaning all of the values, and just say, what is my average class size for mathematics and English? That one was a little tricky. Okay, that one was just a little tricky there. Okay. Again, I see some good stuff. I'll keep going here. We got about 10 minutes left, and we will continue. Number 4 says, Ann Landers, who wrote a daily advice column appearing in newspapers across the country, once asked her readers, if you had to do it over again, would you have children? Oh, I remember this question. Of the more than 10,000 readers who responded, 70% said no. What does this show? Yes. Okay. We already said this. Because of the fact that they're volunteering to be a part of this, let's look at the other answers just in case. This was a legitimate sample. Okay, first of all, if you put that, I will literally hunt you down, and you will be with Beyonce and the Fountain, okay? Even you Sweden followers, all right? The survey would have been more meaningful if she had a control group. What in the world? No, that would have no impact on that survey. And control groups with experimental, not observational, because it's a survey, it's observational. The survey would have been more meaningful if she had picked a random sample of 10,000. No, that has nothing to do with it. It has everything to do with the wording of the question, right? If you had to do it over again, would you have children? Well, first of all, the wording of the question's awful. And then the second thing is the fact that she's asking this, who's going to respond? The people that's going to respond are the people that have had problems, right? Let's look at B, noting meaningful conclusions possible without knowing something more about the characteristics of her readers. That doesn't even have anything to do with it. The characteristics of her readers has nothing to do with it. The people that contacted or that were in would show that it was a voluntary response bias because they were volunteering to be a part of the actual survey. Okay. Question 5, which of the following are true statements? Again, I will cross or X these off as I go or put a question mark as I go. Question 1, voluntary response samples often underrepresent people with strong opinions. So if I have a strong opinion, right, is that going to underrepresent the people? Or response samples often underrepresent. Okay, so think about this. What did this top one do? When we had a voluntary response, didn't it overestimate? Right? It didn't underestimate. Traditionally, that would overestimate, because if I have a strong opinion, like if you say, think about it. If someone said, "Hey, text in, is Michigan good?" Okay? Is Michigan good? First of all, if you say anything different right now, if you laugh at me, I swear to you, I will fail you on this next test. I'm just messing. But if you say, is Michigan good, I'm going to do that, right? The people that are going to contact in are probably the people that are very passionate about Michigan, right? They're going to volunteer to be a part of that. So because of that, that's going to over-represent that, okay? Number 2, convenient samples often lead to undercoverage bias, okay? This is true, right? Because if I just do what's convenient, wouldn't that be exactly what undercoverage bias is, right? It's exactly. That's completely true. Okay. Question 3: questionnaires with non-neutral wording are likely to have response bias. Questionnaires with non-neutral, that's a really weird word, meaning it's not neutral, meaning it's not just status quo, are likely to have response bias. This is true. So the answer would be 2 and 3, which would be C. Okay, that word was weird. And the big thing is knowing undercoverage, bias, voluntary response. Those words are huge for going forward. Okay. Look at the next one. 6 is this. Each of the 30 NBA teams has 12 players. A sample of 60 players is to be chosen as follows. Each team will be asked to place 12 cards with their players' names into a hat. Each team, circle or underline those, okay? Sample of 60. 12 cards with their players' names into a hat and randomly draw 2 names. The 2 names from each team will be combined to make up the sample. Will this method result in a simple random sample of the 360 basketball players? Oh, well, let's look at this, okay? So what is this? This is a stratified, right? Okay. This is a stratified sample. So when we look at a stratified sample, we have to think, okay, is this an SRS of what we're trying to do? Well, let's look at A. A says yes because each player has the same chance of being selected. Well, not necessarily, okay? I see what they're coming from, but not necessarily. 2, yes because each team is equally represented. Well, that doesn't mean that has nothing to do with simple random sample. C is yes because this is an example of stratified sampling, which is a special case of simple. No, that's not a special. It is stratified sampling, but it is not a special case, okay? Letter D, no because the teams are not chosen randomly. Well, it has nothing to do with it, right? Stratified just means that I've got my specific team and all the teams represented, and each team brings in 2, right? From around the league, okay? And D, or E, because because not each group of 60 players has the same chance of being selected. This is correct. Because not each group of 60 players has the same chance of being selected. That would be the correct answer. Think about it. What is the definition of simple random sample, right? What is the definition? Not each group of 60 players has the same chance of being selected. Okay? So just a heads up on that. It's a big thing. Make sure you kind of understand and know that one. That's a biggie there going forward, okay? All right. Let's keep going. Let's keep going there. All right. Let's do this. Hey, do this for me. I'm just feeling. I'm just be very honest with you. On E here, I'm having a hard time explaining this, and I'll usually all the other ones I feel pretty good about. This one on E, I know is the right answer. Could someone in the message box over there just put why this would be? Maybe that would help as y'all kind of talk through this together. Um, Remember the definition of simple random sample. Jordan conveniently put that over on the top here. It's the sample of size n chosen in such a way that every set of n units in the so this is how we could determine this. A sample of size 60 chosen in such a way that every set of 60 units in the population has an equal chance to be the sample actually selected. In this case, it wouldn't be, right? Because it says that not each group of 60 players, yeah, this right here would not be true. Because when we think of each group of 60 players, and this was the difference on the quiz, the fact that when it talks about n units have the same chance of being selected, well, this is not the definition of simple random sample. It's random for sure. It's definitely randomized. But remember, it's when simple random sample is when we have that size of 60 in this case chosen that every set of those 60 in our population has an equal chance of having the same being a part of that sample. Okay, so if you have some questions, maybe we talk through that. I think that made a little more sense. I think I feel a little bit better on that. Just a heads up on that for tomorrow. Let's go two more and then we'll be done, and then I'll flash the other ones up, and feel free to come in tomorrow and get some more help on the remaining, I think, 10 that there are. 7, which of the following are true statements about sampling error? Let's look through the ones. Sampling error can be eliminated only if a survey is both extremely well designed and extremely well conducted. I don't think that that's true. I'm going to put a little question mark on that because when it says it can be eliminated only, that's powerful language. So we're going to come back to that. 2, sampling error concerns natural variation between samples is always present and can be described using probability. Yes, that sounds really good. I like 2. I'm going to stick with that. 3, sampling error is generally smaller when the sample size is larger. Yes, remember when this is larger, decreased variability, right? As it, remember, goes this way and this way, it comes together with our hands. Remember our hands there? In fact, I want you to do it with our hands. Sample size increase, we decrease, right? They decrease the variability. And what happens is the sample error traditionally decreases on that, okay? So with that being said, we would say 2 and 3 are good. Coming back to 1, it only can be eliminated if a survey is extremely well designed and extremely well conducted. That's false, okay? Can only be eliminated if a survey is, well, it's never eliminated, okay? As we see here, it's always present right here. That's a key word. But we can minimize it as we increase that sample size. We can definitely minimize it there. And so 2 and 3 are what we're looking for. All right, what do all these sampling designs have in common? The Wall Street Journal plans to make a prediction for a presidential election based on a survey of its readers. Okay, Wall Street, survey of readers. A radio talk show asked people to phone in their views on whether the United States should pay off its huge debt to the United Nations. On whether talk show asked people to phone. So this is also the people that are listening in and huge debt. A police detective interested in determining the extent of drug use by teenagers randomly picks up a sample of high school students and interviews each one about illegal drug use by the student during the past. So that means that there's definitely history there, right? So all the designs make improper use of stratification. That's not correct. All designs have errors that can lead to strong bias, possibly. All the designs confuse association with cause and effect. Incorrect. D says none of the designs satisfactorily controls for sampling error. Incorrect. And E, none of the designs make use of chance in selecting a sample. I would say 8 is definitely, what? Did I get this one right? Incorrect. Why is the answer D? The answer is D on this one. Let's take a look at it again. I would say definitely All designs make improper use of stratification. All the designs have errors that can lead to oh, hold up. That's the one I thought it was. All the designs confuse association with cause and effect. Yeah, I would throw that out. And I would throw out E. Why would D be the right answer? And I'm looking at it here. None of the designs satisfactorily controls for sampling error. None of the designs satisfactorily controls for sampling error. Man, I think it's B because I guess the errors. I guess that's not really true. I would say that each of these are bias. Like these show forms of bias, don't they? They definitely show forms of bias. None of the designs satisfactorily controls for sampling error. I'm stuck on this one, y'all. I'm stuck on this one. I don't know why it would be D here. The only thing I would say, I don't like any of the answers, to be honest. Should pay off its huge debt. The only thing I could think of is each of these are talking to their readers, right? I would have put B. I swear I would have put B. This says it's D. Let me see. Let me look online real quick. Let's see if we can find it. And maybe it is. Maybe I got that one wrong. That one stumped me a little bit, mainly because of the sampling error. I'm going to put this here as we finish this up. And as we talk through it, the big thing is, again, if you ever have a question on these, talk it through. And this is anyone, right? Anytime I talk it through, even as a teacher, talking through these things are huge here, okay? I actually have an explanation here, which is kind of cool. Oh, I think I just found something that might just blow y'all's mind too. Kind of cool. Okay. Yeah. Okay. So number one has voluntary bias. So only. Oh, I was right. Dang. Okay. They were correct. Actually, this actually works out well. They put the wrong answer on there, so that's my fault there. Okay. So I just found something like extremely cool. Ready? Are you ready for this? This is like money. All right. I'm gonna flash this up here. I did not mean to do this, so I was right. I hate to say I was right, but I was right. So it is B. It's B, 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 B. If you're wanting to do the multiple choice, watch this. You ready? I'm going to flash on the screen one of the coolest things, and you can pause the screen as you go through. Thank you 3 viewers that continued with me. I really appreciate it. I know it's a busy week this week, but great job there. Look at this. This is our multiple choice that we just did. But notice that each of these have, and I'm just going to gradually scroll down, and you can kind of pause this as you need to. I love these few here. Okay, some of these are the same, some of them are not. Okay, but they have actual responses to these, which is pretty cool, right? And some of these are the same, some of them are a little different, but feel free to put those there and pause them. This just was something that I just had found. I thought this was pretty cool. And feel free to pause this as I go through it. Thank you all so much for showing up today, and hopefully this might actually be a huge help there. Go through this, and if you need to, let me know. I could even send this to you if need be. But hey, care about y'all so very much. Have a phenomenal day. Be blessed as always, and go Spartans. Have a great day.